almost 300 miles per hour.
Vector analysis.
With that much wind, strange things are bound to blow around.
Atmospheric anomaly detected.
Like this, the famous red spot. The red spot is a rotating high-pressure system. Weather, in other words. And it's a storm that's been churning for well over 100 years, likely observed in even the earliest telescopic observations of the planet.
NASA assembled this image from a number of different satellites to look like the Earth on a typical day. The vegetation detail comes from the MODIS sensor, and the clouds are a composite of 3 days visible cloud imagery taken in 2001. For most of us, this is probably the closest we'll ever get to being an astronaut in outer space, looking back at the Earth. You are now looking at a computer-generated picture of the Earth's topography and bathymetry developed by NOAA. The computer uses color to distinguish features on the planet. On the land, the color gray and gray under the ocean. The mid-Atlantic ridge is a striking feature that splits the Atlantic Ocean down the middle and is in fact the planet's longest mountain range. Liquid hot magma is constantly being pushed up from the planet's core along ongoing plate tectonic forces that have shaped our planet over billions of years.
Now please walk slowly to the other side of the sphere for something completely different.
Here, on the dark side of the Earth, are the lights of the Earth at night. This data comes from a network of polar orbiting satellites in the Defense Meteorological Satellite Program. These satellites circle the planet at tremendous speeds between 8 to 15,000 miles per hour. The satellites take pictures constantly as they pass over the Earth, and scientists and computers.
An ocean current is a continuous movement of water. Currents are created by wind, gravity, or differences in temperature and salt. The colors on the globe show different speed. Blue areas are slow-moving currents. Green areas are faster, and the yellows and reds are moving even faster. Ocean currents move warm water toward the poles and bring polar satellites hover 22,300 miles above the Earth, while polar orbiting satellites fly pole to pole at a height of 450 miles. Watch as the 4 different colored polar orbiting satellites travel around the Earth. The blue satellites are used by the National Weather Service. The red satellites are used by NASA, and the yellow ones are used by the U.S. Defense Department. The smaller white satellite is the International Space Station. It may look like the satellites are crashing together, but each of the polar orbiting satellites fly at a slightly different height.
Now, let's take a look at an X-ray image of our Sun, which allows us to see its outer atmosphere, called the corona. The corona is where the solar storms are occurring, those white flashes you see periodically. This data set is derived from a sensor located on the NOAA GOES weather satellite. The space environment agrees, meaning Mars has seasons, just like the Earth. Other similarities include land features such as canyons, mountains, and polar ice caps. If you've been to the Grand Canyon, you know that it is very deep. It is actually more than 1 mile deep and over 200 miles long. On Mars, notice the long gash in its southern hemisphere. That is the Mariner Valley. It is over 2,500 miles long and 5 miles deep.
How big is it?
Analyzing.
This is Earth. This is Earth compared to Jupiter. It would take more than 1,000 Earths to fill the 5th planet. But our journey today fixes a bullseye on Jupiter.
Referencing data index. Telemetry archive online.
Most of the images you'll see come from various spacecraft that made the trip.
Data now available.
For example, Voyager 2 collected this remarkable sequence in 1979. Movies of Jupiter are exceedingly rare.
Approaching area access.
Most visiting spacecraft simply use Jupiter's immense gravity as a slingshot of even casual visitors. Jupiter's face is an opaque, seething mask, ever-changing, revealing nothing of the small, dense core, tens of thousands of miles below.
Hydrogen helium atmosphere.
The planet's extraordinary rotation speed keeps the grinding sky in constant motion. The huge planet makes a complete revolution in just 10 hours.
Enhancing